the position vector of a particle p relative to a fixed origin at time t is given by. Question A, find the velocity of p. First of all, notice that the velocity is a vector and speed is a scalar, it's a magnitude of the velocity vector, and OP, its position vector, R is the same as displacement from the origin. Velocity, its rate of change of the displacement, its derivative, and acceleration, its derivative of velocity because it's rate of change of velocity, or second derivative of displacement or position vector. And in opposite direction, velocity, its integral of acceleration, displacement, or position with time, its integral of velocity. So velocity is just derivative of this vector. So we should consider it just derivative of this vector. So velocity, its x components, its derivative of sine of t squared, and how to take this derivative. You can see that it looks like sine of x or of t, but here we can see that there is more complicated argument, and we should apply what? Chain rule. And let's repeat what is chain rule. For example, we know that sine x derivative, it's cosine. It is given in a data booklet, but if it's sine of x to the power of 10 or sine to the power of 10 of x, here you can see that it's just sine without power. It's just sine, but of more complicated argument. And to find the derivative, here we apply the same formula as for just sine and keep the same argument, so it becomes cosine of x to the power of 10, and then it should be multiplied by argument derivative, and finally it becomes what? Its derivative, it's what? It's 10x to the power of 9 cosine of x to the power of 10. But here you can see that sine is to the power of 10, its function is to some power, and here we apply the same rule as for x to the power of 10, but we write sine instead of x, so it becomes 10 sine to the power of 9, and then multiplied by this derivative, so sine x derivative. So finally it's 10 sine to the power of 9 of x multiplied by cosine of x. Here we can see that there is no power but more complicated argument, so it becomes cosine, sine derivative, it's cosine of t squared, and multiplied by t squared derivative, which is just 2t. It's x component, and y component becomes what? Cosine. The same, but for cosine derivative, it's negative sine multiplied by what? T squared derivative, which is 2t, so it's negative 2t sine of t squared, and it's the required velocity vector. The next shows that the acceleration vector of p is never parallel to the position vector of p. Acceleration vector can be found as derivative of velocity vector. Acceleration is derivative of velocity, and we should take derivative of this. And here you can see it's something with t multiplied by something with t, so we should consider it as a product of two functions. And we should apply product rule, and it says uv derivative, it's u derivative times v plus uv derivative. So it becomes 2t derivative multiplied by just cosine plus 2t multiplied by cosine of t squared derivative, and negative 2t derivative multiplied by sine plus or minus or plus negative, it's just minus 2t sine derivative, and it becomes 2t derivative, it's just 2, so 2 cosine of t squared plus 2t multiplied by cosine of t squared derivative, and cosine of t squared derivative is this. So it's just additionally multiplied by 2t, so it becomes finally what? 2t multiplied by this, so it's minus 4t squared sine of t squared. Cosine derivative is already found, is this. We just take this directly. And y component becomes negative 2 sine of t squared, and sine derivative is 2t cosine, so minus 4t squared cosine of t squared. And we need show that the acceleration is now parallel to the position vector. Position vector is this. And when two vectors are parallel, for example, two vectors 2, 3 and 20, 30 are parallel. Why? Because one vector can be represented as some constant multiplied by another vector, or such components are proportional. We can make like this: 2 over 3 is the same as 20 over 30, or 2 over 20 is the same as is equal to 3 over 30. And we can consider such a proportion, and when this proportion exists, it means two vectors are parallel. And here, since two vectors are not parallel, we should get some contradiction or something like that. So let's consider a proportion and what vectors should be considered: its acceleration and this OP. So, and let's make proportions that x over y here is equal to x over y here. So it becomes sine of t squared over cosine of t squared is equal to 2 cosine of t squared minus 4 t squared sine of t squared negative 2 sine and minus 4 t squared cosine. And we can divide each term in the numerator and denominator here by 2. We can divide by 2 each term, and actually we can divide by minus 1 to be more simpler. And then let's consider cross multiplication, because if proportion fraction is equal to fraction, now let's consider cross multiplication. Or I write like this, and just 2 and 2 here. And cross multiplication becomes, and let I rewrite quickly. So it becomes sine of t squared over cosine of t squared is negative cosine of t squared plus 2 t squared sine of t squared plus 2 t squared cosine. And cross multiplication, sine squared of t squared plus 2 t squared sine t squared cosine t squared, and this product is equal to what? A negative cosine of t squared and cosine squared, and plus 2t squared sine t squared and cosine t squared, and you can see that it cancels, and we get that sine squared of t squared is negative cosine of t squared, and we can see that it's positive and also positive. So positive is equal to negative positive, which is impossible, so a contradiction arises. Contradiction arises, and it would be better here to write assume OP vector and what a vector are parallel. Then if they are parallel, components should be proportional, so we can see the x over x is y over y, and contradiction arises, hence our assumption is not true, therefore OP and R cannot be parallel, or what it is given is never parallel. R never parallel. And that's all for this question, but notice that you should also know that a particle is moving in a circle. Trajectory is a circle when x squared plus y squared is equal to some number, and this number is a radius squared, and center is at origin, and position vector, it starts at the origin, and actually it gives us x coordinate of a particle and y coordinate at any moment of time. And if we consider here x squared plus y squared, it becomes sine squared of t squared plus cosine squared of t squared is equal to, we consider this, and it is given in the data booklet, the next formula, which is called the main trigonometric identities, that sine squared of some angle plus cosine squared of the same angle is equal to 1, and hence here x squared plus y squared is equal to 1, and this particle is moving in a circle. And if you meet a question that something about trajectory of a particle related to circle, or if for example it is given that x squared plus y squared is equal to something, you should understand that if question about a circle or suggested the trajectory is a circle, equation of a circle is this, and this value it's radius squared, so radius is root of this number, so here it's just 1. And that's all for this question.